Now, we've talked about regular shapes, and in this lesson here, we're going to really focus on ones that are not regular, okay? Not regular, but we're going to look at ones that we can solve using regular shapes. Now, objects which are not regular shapes can be thought of as irregular or composite shapes. Okay, so we have two different words for it. One is irregular, the other one is composite. Now, the first word that I used there was irregular, and irregular and composite do mean the different things. So irregular shapes have no distinct pattern, okay, and are often more abstract. Okay, so you think of them as being abstract. There's usually not a lot of straight lines. There's not a lot of distinctive shapes in there. Calculating the area of these shapes is not possible with the formulas that we have. Okay, so it's not possible with the formulas that we have. An example of what that might look like, and again, these can be drawn just with a regular pen, would be something like this. Okay, can we find the area of that shape? Well, I'm not really going to get you to do that because finding that would mean we'd probably have to come up with a grid pattern here. We have to count up our squares. We have to estimate our small squares and our big squares and how many we have. And we have to try to come up with some sort of plan. Okay. It's just not going to work. We're not going to do it that way. We're going to leave it at those are irregular. Okay, we're not worrying about finding the area of a shape like that. Now, on the other side, and these ones we will be taking a look at, regular shapes, or sorry, composite shapes. Okay, so composite shapes are ones which have a combination of regular shapes. Okay, so they have a combination of regular shapes. The area of these shapes can be found by using the equations of regular shapes and then combining them together. Okay, so we can, if we want to try to find the area of a regular shape, we start with the we start with finding regular, if we want to find an area of a composite shape, we start by finding the regular shapes that are in there and then moving that into the entire shape. And we're going to be taking a look at a few different examples of that, and we're going to start here right away with example number 1. So example number 1 here, we're going to be taking a look at when two or more shapes are combined together. Okay, so there are 3 different types of composite shapes and 3 different things that we can look at. The first one is where 2 or more shapes are combined together into one individual shape. And so we look here at this one, we have this rectangle which has been attached to a semicircle or a half circle. Okay, so this is the first one that we're given. To find the area of these here, the first thing that we want to do is we're going to draw lines in the composite shape to break it into regular solvable shapes. Now, sometimes those lines are actually already going to be given. In this case here, we are kind of given that line already, and it's going to be right here. Whoops, I'm drawing the wrong thing. Let's do this here. All right, so this is our line right here. It's a little tough to see. Okay, we have 2 shapes. We have this rectangle and we have this semicircle. Okay, the first thing we need to do is figure out which shapes do we have. Okay, and we have that pretty clearly here. We have, and I'm just going to quickly draw in a little bit so we can see. We have this rectangle right here, and on the other side we have this semicircle right here, and they are 2 distinct shapes or looking shapes, but they've been combined together into one. The next thing that we need to do is we need to calculate the area of each regular shape. Okay, so we calculate the area of each regular shape. And I'm going to start off with doing the rectangle. Okay, so the rectangle, we know that area is equal to length times width. And so that tells us that our area is equal to 8 centimeters times 12 centimeters. And doing the calculations here, 8 times 12 is 96 centimeters squared. There we go. There is our rectangle. The next thing we do is we solve for the semicircle, okay, or the half circle. Now the way that we do this is we're going to do pi times r squared, and then we're going to divide that all by 2 because it is half of a circle. Okay? It is half of a circle. So we divide it by 2 because it's half a circle. If you want to do divide by 2 behind it, you can do that. I'm going to put it in like this here. Okay, so we solve for that. We do pi, and then we're going to multiply it by the radius. Now you'll notice that the radius of the semicircle is not given, but we can interpolate or kind of use other knowledge to determine that if this side here is 8, this side here also has to be 8. Okay, so we can kind of transfer that over to this side. So that tells us that the radius is in fact 4 centimeters. And here I'll do divide by 2. Again, it works both ways to do that. Okay, so then we do the calculations, and I'm going to use my calculator. Okay, with the first one I didn't have to, but this one I'm definitely going to need that. Pi times 4 squared divided by 2 gives me 25.13 centimeters squared. Now again, important thing is that we keep our units intact. Okay, when you deal with centimeters, so that means everything is going to be in centimeters. The next thing that we do to solve is we add, in this case here, we add the areas of each shape together. Okay. We add each, sorry, that's not together, should be to determine. Okay. We add the areas of each shape to determine the area of the composite shape. So what we're going to have here is we're going to have total area is equal to 96 centimeters squared plus 25.13 centimeters squared. And so our total area is equal to, we're going to add up, then again, use the calculator, 121.13 centimeters squared. And that is our total area. Okay, that's our total area. We've combined the two shapes. Now, in some cases, we're going to have just two shapes. Other times, we're going to have more than two shapes. Okay? Break it into whichever shapes we have. If that means there's 2, 3, 4, 100, we break it into those shapes, and then we solve for each of those shapes. Now, one little thing just to be aware of, sometimes, and in this case here, we had that a half shape, or half shapes are used instead of the full shape. Okay, so sometimes we use half shapes instead of full shapes. Again, putting a full circle on there wouldn't really seem like a combination shape, but a half circle definitely works. If we do see that, okay, we take the full formula and we divide by 2. So we take the full formula, we divide by 2, just like I did here. Area is pi times radius squared. We divide by 2 because we got half of the circle. Okay, we've got half of the circle, and that gives us an opportunity to be able to solve for the that half circle. Again, if you want to show it in the formula here, if you want to divide by 2 later on, you can do that as well. All right, finally here, I'd like you to work on questions 2 and 3. Okay, so work on questions 2 and 3, solving for the area, and remember to be careful about units as well. Here I've kept my units in there. Make sure that you're keeping your units in yours as well.